So typically a line graph let's say you have ungrouped data. So let's say we have something like this. Let's say we're rolling a die, a fair die, and we're saying the frequency or the relative frequency that each one of these outcomes come up, the face of a die, right? So let's say we have frequency over here. And let's say we roll it 600 times, whatever. I mean, so let's say this is 100, frequency of 100. And so let's say we have this bar chart. Well, each bar has a height. Well, if we replace that height with a dot, then we could say, okay, well, we could get something maybe like this. Okay, so a line graph means that we would take the height of each bar, the height, the frequency, right, the height, and we would just connect the dots with a straight line. And that's a line graph. And that's it. So that's a typical line graph. Okay, this would be for ungrouped data. Okay, so each tick mark represents an outcome. The height of that outcome, the frequency, is represented by a dot, and then you just connect the dots with a straight line. Okay? Don't use smooth lines, especially if you do the Excel. Always use straight lines. Okay? So now, what if we deal with, oh, here's another example. Okay. What if we do grouped data? Okay. Well, with grouped data, we're going to introduce a very specific line graph called a frequency polygon. Okay. Now, to construct a frequency polygon, this is used with continuous data. So a typical line graph is used with specific observed data, so ungrouped data. Okay, so discrete data sets. Okay, so but what if I have continuous data? Okay, so that means I'm going to have to group it. So this is again grouped data. So here's an example of how I would construct a frequency polygon. And so this is going to be bringing in the concept of the midpoint of a class. Okay, so this is going to be something new. Okay, so again, this is the way I would construct the graph or the table. Okay, so this is examples calculus final test scores. Okay, so calculus. Okay, so here's my table. Hold on. So I have okay, so this is going to be my, and again, you could just do class limits here. It doesn't matter if you use class boundaries or class limits for this case. It's not going to change the midpoint of the class. So I'm just going to use class limits. So this is going to be lower class limit and upper class limit. Okay? And so we have 50, 60, 70, 80, 90. And again, below 50 or below is an F. So it doesn't matter if they fall below this. And in this case, none of the students fall below that. But again, just for example, so this is going to be 59, 69, 79, 89, and 99. Okay? And so here's the frequencies. So we got 5, 10, 30, 40, and 15. Okay? So you can sort of see kind of a distribution here, 5, 10. So it's increasing to a peak and then decreases. So this is definitely skewed left. So you've got a few people here that are at or below. You got more people that are below 40 versus above 40. Okay, so it's definitely skewed down. Okay, but you've got a majority of the people that got into the B range, that were in the B range. So that's good. Okay, so you need the midpoints. So that's the main thing. So two things you need to create a polygon, frequency polygon, is you need the midpoints. That's the first thing. And you need to add a class to the top and the bottom, to the lower and to the higher one. Okay, and I'll show you what I mean by that. So what I need to do is, because a polygon needs to touch the x-axis, to be a polygon, it has to be a closed shape, right? So again, hence the name polygon. So what we're going to do is we're going to add a class to the beginning, and we're going to add a class to the end, but we're going to make the frequency automatically 0, so it forces the line to go to the axis, the x-axis. Okay? So here's what I'm going to do. I'm going to add a class to the top and the bottom. Okay? And it's not going to mean anything other than just for a placeholder. So again, here's the lower class limit, upper class limit, and frequency. So what's the frequency going to be for this one? 0. What's the frequency going to be for this one? 0. And so now what's my lower and upper class limits? Well, this one's going to go from 40 to 49. And this one's going to go from 100 to 109. Okay? Again, it doesn't mean anything other than just for graphical purposes, or purposes of graphing. Okay? So now, what's the class width here? Well, the class width is what? Well, to find the class width, you just subtract one class limit from the other class limit. So 40 minus 50 is 10, so the class limit is 10. Okay? So the easiest way to figure out all of the midpoints of the classes is find the first one and then add the class limit. Okay? So what's the midpoint between these two class limits? Well, what do? You add the two class limits and divide by 2. That's it. So you add the two class limits, so upper and lower, or lower and upper, and divide by 2. So we're going to do 40 plus 49 divided by 2. What does that equal? Well, it's going to be the halfway point between these two, which is going to be 44.5. Is that right? Yep, because this is 89. 89 divided by 2 is 45 and a half. Or excuse me, is that right? 45? No, 44 and a half, that's right. Okay? So because you get 89. Okay? because half of 80 is 40, half of 9 is 4.5. There it is. Okay? So now we got the first one, 44.5. So what's the next one? Just add 10. So it's 54.5, 64.5, 74.5, 84.5, 94.5, and 104.5. So now I've got everything I need to construct my frequency polygon. So again, make sure you have this written down because I'm going to erase it. I'm going to construct the frequency polygon and we'll be finished with that. Okay, so now, what am I going to do? The heights of each one of these is going to be at the midpoints, okay? And the vertical axis, the y-axis, is going to be the frequencies. Again, you could do the same thing for relative frequencies. I'm just going to do it for frequencies. So you could construct the relative frequency polygon. The only thing that's going to be different is what you use for the y-axis scale, okay? So here, each one of these is going to be where I'm going to plot. And again, since I'm not going to, I'm breaking the graph here, so I'm going to put a little break in the graph. Okay, so this is going to start at 0. And then my first tick mark, let's do it this way. Hold on. And remember, I want to have these equally spaced. Okay, so I have 5. So the first midpoint is going to be 44.5. And then 54.5, and then 64.5, 74.5, 84.5, 94.5, and 104.5. Now, what's the frequency of these two outside classes that we added? 0. So we're just going to put a dot here at 0 and a dot here at 0 because the height is 0, right? So this is going to be frequencies. Remember, frequencies over here. So this is going to go up by equal amounts. And so what are the frequencies that we have? Well, it goes from 5, so 5 to 40. So let's go up by increments of 5. That's easy. So this will be 5, 10, 15, 20, 25, 30, 35, 40. There we go. Okay, so now, what's the height of this? The first bar is 5. Well, the first bar is going to be, we're just going to put a dot at 5, like that, okay? Or close to it. Okay? Again, it doesn't have to be perfect. The next one is going to be at 10. Okay, so the next one is going to be at 10. And the next one's going to be at 30. And the next one's going to be at 40. And the last one is going to be a 15. Okay, so now I've got this. Now what I'm going to do, the last step, connect the dots with a straight line. So I'm going to go from here, here to here, and then here to here. And then I'm going to go, oops. Right there. There to there. There to there. There to there. Okay? And there's my frequency polygon. And notice that it indeed makes a polygon, because if you trace this out, It makes a polygon, right? Any questions? Okay, good. Well, that is how you construct the frequency polygon. Remember, midpoints and the frequencies, okay? So that's how we do it. This is a type of line graph that we use for grouped frequencies, grouped frequency distributions, okay, versus ungrouped, okay? Okay, so the next thing is time series. So time series is the last one that we're going to cover in this section. And this is used with any type of data that is dependent on time. That's any kind of time increment. So in this case here, the x-axis, the horizontal axis, is always going to be some increment of time. So it could be seconds, it could be hours, it could be months, days, seasons, okay? Anything that's related to time in that manner, okay? So let's look at a couple of things. So the horizontal axis is always going to be some increment of time. Hence the name time series. Okay? This is very common. All kinds of things use, there's lots of different scenarios that use time series graphs. You talk about stock prices, changing over time. The life cycle of apparel. Any kind of apparel has a life cycle over the seasonal, right? Seasonal cyclic patterns, right? So you have this fall apparel versus spring and summer, winter, fall. So it always has a cyclic pattern to it. So that's going to be time series. Temperature obviously is going to be cyclical and changes over time. Okay, anything that changes over time is going to be a candidate for a time series graph. Okay, so the x-axis is always going to be time, some increment of time. The vertical axis, y-axis, is going to be whatever you're measuring, okay? Whatever increment you're measuring, whatever the value that you're measuring, okay? Could be frequency, doesn't have to be frequency. It could be dollars, right? If you're talking about stock prices. It could be temperature. It could be the height of a tree, the diameter of a tree over time, okay? It could be lots of things. Okay, weight, right? Weight of a child, a newborn baby, the weight of a newborn baby over the first year. So that could be monthly, right? So lots of different things you could do. Okay, so here's an example. So here's an example of a time series that uses the annual consumer product index, okay? So this is the annual consumer product over time. So here, it's going to be annual, okay? So we're going to start with annual increments. So the x-axis is going to be year. So this is going to start with 2003. Again, I'm going to write it at an angle to save room. So 2003, and it's going to go up by year. Okay, so here's the year. So this is annual. Okay, so this is year. And the y-axis is going to be the annual, what we call the consumer product index. Okay, CPI. Okay, and this is going to be in the hundreds. So again, this is going to be and I'm going to break the graph on the vertical axis now, because I'm starting at 0, but again, this is in the hundreds, so I don't want to start at 0 all the way up to 100. So this goes from 184 to 229. So I'm going to start at 180, and I'm going to go up by 5s. You know what? I'm going to go up by 10s. It's not going to matter in this case. Sorry if you have to change, but I'm going to go by 10s. Okay, and so this is CPI. And so I'm going to plot, again, I'm going to just use a dot to represent the height. Okay, so at 2003, the CPA was 184, so I'm going to put it right about there. And then it goes up to 188.9. So 188.9, I'll say is about maybe right there. And then 195.3. So 195.3, about right there. And then 201.6, 201.6, so that's going to be right about there. And then 207.342. So 207, let's say is about right there. Okay, so 207.342, and then it goes up to 215.303. 215.303. So this is the actual data. So 215.303. So 215.303. So that's going to be somewhere right there. And then 214.537. So that's going to be right about around there. 218.056. Hold on a second. Oh my gosh. I knew I did something wrong. Wasn't looking right. So this is 9, 10, 11, 12. There we go. Okay. Okay, so everything looks good. So 2011. Okay. So then it goes up to 218.056. So 218, let's see, is about right about, maybe right around there. Okay. And maybe a little. Okay. And then 220, oh, something's not right here. I'm missing something. Oh, hold on, I don't think I wrote down all the numbers. Oh, no, that's right. Okay, that's right. So, okay. So we got 84, 88, 95, 201, 2. So 184, 188, 195, 201, which is probably should be up here. 207. 215. Yeah. 214. 218. Oh my gosh, I did the same thing I did before. It's been long already. 8, now this is 9, 10, 11. Okay, I knew it wasn't adding up. Sorry about that. Okay. Okay, it's a good thing I'm videotaping this so you can skip all this. Okay, so now I know I'm right. Okay, so 18, now 224.93, so about 225. So 225 is right about there. And then 229, so almost 230, and that's going to be right about there. So now here's it. So the only thing we have to do is now just connect the dots. And there's your time series graph. Okay, so again, you can see trends, right? So this is a great way to see trends over time. So normally, so you see, now, they don't give me what we're looking at. So it's, I don't know for what country or who this is for, but it's just annual, the consumer price index over a year. So I don't know where this pertains to, but again, you can see that there's a general trend of increasing over the last 10 years that the consumer price index has trended upward, which is a good thing, okay? Okay, so that's time series. So that ends this section over graphical displays for numerical data. I hope it was worth your time. I hope you understand it more. And again, if you have any questions regarding any of this or concepts that we've covered, please email me, let me know in class. I'd be more than happy to help. Talk to you soon. See you in class.